Today we're talking about circles, which are the simplest of all of the conic sections. They're just much more straightforward and easier to visualize than really any of the others, and you have the most experience. You've known what a circle was probably since you were a toddler, so this is a very familiar shape. I'm not going to talk a lot about the stuff that's up here in this blue box. You can all read that for yourself. You already know that the center of the circle, the distance from the center to the edge of the circle is called the radius, and twice that distance is the diameter. You're familiar with all that. I will help you make a couple of connections. So the equation for a circle is x squared plus y squared equals r squared. And if you think about that, you'll realize that's awfully similar to the Pythagorean theorem. That's clearly connected. And the distance formula can be used to calculate the distance from the center out to the side of the circle. It can be used, and so that could be the radius. And this all really just goes back to the Pythagorean theorem. We're going to jump down here to what we would consider the standard form of an equation of a circle. So now I just want to talk about standard form for a second. We're used to thinking back in Unit 4 of the standard form of a parabola being y equals ax squared plus bx plus c. But when we get into conic sections, that's not standard form anymore. Now in conic sections, so in Unit 9, standard form parabola is actually what we've always known before to be vertex form. So that's going to be a little weird for us. Standard form for a circle is going to be this x minus h all squared plus y minus k all squared equals r squared. So when we're talking conic sections, because we're not bound by everything always needing to be a function, in fact, a circle is clearly never a function, our ideas of what should be standard form is a little bit different. So when we're in Unit 9 and I ask you to put an equation in standard form, think vertex form. That's what we mean by the standard form of any conic section when that's our context. Let's jump right into solving some problems. Unlike with parabolas where we started with everything focused on the origin, we're going to immediately move off the origin with circles because frankly, circles are way too boring if you keep them centered at the origin. So number 1 is asking us to write a translated equation, and you have done this so many times before in the previous units. So this says, what's the equation for the translation of x squared plus y squared equals 10 by 2 units right and 5 units down? Okay, so first of all, we're going to be in this x minus h squared plus y minus k squared equals r squared format. Well, that number 10 isn't going to change because it controls the size of the circle, right? It's the square of the radius. So it has nothing to do with whether or not it's been translated. But we're going to have an h and k now because we're moving 2 units right, which we know is a move in the positive direction. Well, since it's x minus h, it's going to be x minus 2. Both the h's and the k's are going to appear as opposites when we work in conic sections. And we're going 5 units down. Well, that's a negative direction. So when I look at it in the equation, I'm going to see a positive value. Oh, sorry, that's a 5, not a 2. And so that's my equation for this translated circle. And there's truly no more work to be done than that. All right, now we're asked, you row a boat from the water's edge to the center of a circular pond, located 30 feet north and 80 feet west of your starting point. If the location where you began rowing is the origin, what equation represents the water's edge around the pond? Okay, so they're telling us that this is a circular pond. So let's assume perfect man-made pond, not naturally occurring, strangely shaped pond. So if I let the location where we begin rowing be the origin, that lets me center my circle at the origin, I believe. Let me look. Oh, no, from the water's edge to the center. So actually the center is not at the origin. We row from the edge of the pond to the center at 30 feet north and 80 feet west. So 30 feet north and 80 feet west would be somewhere over here. So that means that this distance here is my radius, and the circle is going to come around from there. Sorry, that's my bad circle because I ran out of space. All right, so if this is 30 feet north, that's my y value, and 80 feet west, I've got negative 80 as my x value for my center. So I start writing my equation right away. I've got x plus 80 all squared plus y minus 30 all squared. But the issue is I don't know the length of the radius. And actually, I don't care what the length of the radius is. I care what the square of the radius is. So let's think for a minute. If we drop this right triangle down, that's going to form my radius. And all we really care about is r squared. So if we went 80 units to the west, right, that's a negative number, but all we really care about here is length. And 30 units north, well, r squared can be found with my Pythagorean theorem. That's going to be 30 squared plus 80 squared. And I don't even need to take the square root because I want r squared for my equation. So 30 squared will be 900 and 80 squared will be 6,400. So we've got 7,300 as our r squared. So that's the number that goes in. And you now have an equation for that circle. Now, in number 3, we get our very first experience with double completing the square. I know you're so excited. So we need a little bit of reorganizing in order to make this manageable. And the first bit of reorganizing that I would do is put all the x's together and put all the y's together. So I've got an x squared and a plus 2x, and I know I'm going to have to add something to the mix to complete the square on the x's. And then I've got a positive y squared and a negative 6y, and I'm going to have to add something to both sides to complete the square for y. So on the other side, I still have that 6, but I need to put in 2 blanks so I remember that both acts of completing the square get counted. So let's think about this factorization. I'm going to have x plus or minus something all squared and y plus or minus something all squared. Well, if 2 is my middle term on the x, half of that is 1, and 1 squared is 1. So that's the first thing I'm adding to both sides. For my y's, if I have negative 6 as my middle term, half of that is negative 3. And when I square that, that tells me to add 9 to both sides. So that's going to be a 16 for my radius squared. And now I have the standard form for the equation of that circle in terms of conic sections, which will give me all the information I need. I can now see that the center is at negative 1, 3, while the radius is the square root of 16. So the radius has a length of 4. And that's all they wanted me to know. All right. Finally, we're going to draw a circle. I know that sounds really silly, but that's literally what we need to do. So as I look at this equation, it's in standard form conveniently. So I can say that the center is at 0, 1, right? Nothing was being added or subtracted to x, but 1 was being subtracted for y, which means it's moved up 1. I can see that r squared is 16, so r is 4, right? This is talking about the length of a radius, so we don't need the plus or minus. So when I go to my graph, I can leave the axes pretty much in the center because 0, 1 hasn't moved very far at all, although it looks like there might not be a center line here. So I'm just going to get as close to the center as I can. If you want to, you could move it down slightly because the circle is translated up just a bit. So the first thing we're going to do is graph the center at 0, 1. Now the radius is 4 units long. So if I count 4 units up from the center, that would be the uppermost point of my circle. If I go out 4 to the side, down 4, and 4 to the left, I've got like the 4 extreme points there. So now if I want to draw my circle, I find it works best to draw a quarter of the circle at a time, which is actually a skill they teach in mechanical drawing. That the way to draw a circle freehand when you don't have a compass is to draw 1/4 of the circle at a time. And it helps it not to look like, a rectangle or some sort of awkward, lumpy triangle. So there's my circle. I would label the center and I would label the 4 points that I use to graph. And that would be considered a full credit graph for a circle. You should now be ready to do the lesson 2 daily practice.